Hey folks, we're going to take a look at some calculator skills, some review of how calculators work. So the order of operations, I did this a little bit on the common algebraic errors notes. So I'm just going to review it and go fairly quick again. The order of operations, you probably remember it from elementary as please excuse my dear Aunt Sally, PEMDAS. The reason I don't like PEMDAS is because it is a little confusing, multiplication and division and addition and subtraction. So I like to think about it, and plus it ignores one of the bigger operations called roots. So I like to think of it as a house. This house has 3 floors and then a penthouse or an attic or whatever you want to think of as the top part. And in this house, we have operations. At the bottom floor, we have addition and subtraction. The next floor, we have multiplication and division. And then at the top, we have exponents and roots. Now, we put these together in this fashion because exponents and roots are inverses of each other. They're the same operation from a different perspective. Same thing with multiply and divide. Multiplying and dividing, if I wanted to divide by 3, I could do that by multiplying by 1/3. Those are the same thing that will give you the same result. So multiplication and division can be quickly turned into each other. And then we have addition and subtraction, same sort of argument. At the very top, we have parentheses. Now, parentheses is the only man-made version of this. If you went to another planet in the universe and they were developed enough to have mathematics, they would do the order of operations in the exact same order that we do, except for parentheses. Parentheses is first because we as humans decided that it would be first. So the way we do the order of operations is we start from the top and we work our way to the bottom. So why do we do it in the order that we do it? Why do we have to do exponents before we do, let's say, multiplication? So why exponents before mult? Now, it's not because there's some old dead guy who said that you have to do it in this order. It's because what do exponents mean? What does 2 to the third mean? It means 2 times 2 times 2. So exponents are actually hidden multiplication. So I can't do the real multiplication until I do the multiplication that's hidden within exponents. And that same argument, why do we have to do multiply before we do add? Well, again, what does 2 times 3 mean? Not the answer, but what does it mean? It means 2 added together 3 times. It gives us an answer of 6. So the reason you have to do multiply before you do addition is because it's hidden addition. So that's why the order of operations work the way that they do. What's nice about our calculator is that our calculator does the order of operations for us. So as we compute these things, you don't have to worry about how you type something like this in. The calculator knows to do the multiply. It knows to do the square root, and then it knows to take those answers and add them together. It already knows how to do it. So we're just going to practice some of the tricks that come with using a TI-80 for operating system. All right, so let's evaluate negative 2 times 3 plus square root of 5. So remember, there's a difference between the subtract button and the negative button. So negative 2 times 3 plus, and then the square root is above squared. It's in blue, so you hit the second button first, and it creates a square root, and it spits back this number. So we got blah, blah, blah is the same as negative 3.763. Now, your goal on these is not just to get the right answer, it's to use the trick that we're doing and get the right answer. So I don't want you to just retype this. Our goal here is to use either the answer button or the store button to get the correct solution. So in other words, the point of this example is if you see this chunk gets put in there and it gets put in there. Now you could retype the whole thing, but one of the tricks of our calculator is it'll take the last answer and it'll put it in that place. So instead of 4 times all that stuff, if you look above the negative, I can hit second and then there's the answer button. And it takes that answer and it puts it in there. Subtract 3 times and I could select the answer button and it takes that in there, and then I can go to the second and it'll spit back the correct answer of negative 57.557. Now, as you notice, in this class, we truncate in AP Calc. We don't round properly anymore. We truncate at 3 decimal places. So if you look at this one, it kind of feels like we didn't round it correctly. The College Board expects you to truncate. So it's just go to the third one and then write it down. Don't write anything after that. Now let's do the same thing, but let's do it where we get the store key. So what I'm going to do is now I can't use this because that's the new answer. What I want to do is I'm going to clear and I'm going to go up until I get that answer again. Okay, now this time I'm going to store. That's next to the 1. It'll say take the answer and then the arrow means store, and then I'm going to hit alpha and A. What that does is it takes now the variable A and it's going to be worth negative 3.76 blah 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 blah. So instead of doing 4 times answer, I'm going to do 4 alpha A subtract 3 alpha A squared, and it spits back our negative 57.557. So there's going to be times in class where we're going to want to store an answer as a variable and then use that variable again. And I'll remind you of this when we get to those topics. All right, so here we go. Next up, we're going to review the second enter, the insert, and the delete versus clear buttons on our calculator. So let's start off by typing this one is, I want to do the square root of 5 plus 14. Now you'll notice that the square root stops here. So I got to hit the over arrow to get out of the square root. Then I have a subtract. Then I have a quantity of 8 times 3, subtract 24. And then that goes to the exponent. That means this to the button up here. Fourth, and our calc spits back 4.358. Now again, if you start typing and you type this in, yeah, you'll get the right answer. But the goal here is to use some of our calculator tricks to not have to save us some headaches. Because if you notice, this problem and this problem are almost exactly the same, except this just needs to be a negative 5. So what I'm going to do is I'm going to hit second and enter. And what that does is it brings up the last thing that I typed in. And I'm going to push my cursor until I get to the 5. Now, if I hit negative here, what happens is it'll delete the 5. So if I just hit negative, it's in what we call overwrite mode. So if I just hit negative, it changes the 5 into a negative. I don't want to change it into a negative. I want to change it into negative 5. So what I'm going to use is the insert button, which is above delete, second insert. Now I hit the negative, and it inserts a negative and slides everything else down. A lot of kids then move the cursor to the end. You do not have to do that. Your calculator will calculate it at any point. So I hit enter and I get the answer of 3. Okay, now I want to evaluate this. And this, if you look at this, now we're real close to what we had before, except now it's back to being a 5, and this 24 is now a 23. So I'm going to hit second enter again to bring up what I had before. I'm going to change the 4 to a 3. So I don't want to insert, I want to overwrite. So that turned that into a 3, and then I'm going to go here, and I want to get rid of this negative. Now, if you hit clear, it'll clear the whole screen. You do not want to clear. We just want to delete this one thing, then hit enter, and we get our 3.358 result on our calc. So there's a quick review of how second enter brings up what you had before, how insert slides things down, and how delete kills one thing in the expression instead of the whole thing. So now watch, when I hit clear here, I get the whole new screen. Okay, so next up we're going to evaluate the fifth root of 127. So there are 2 places that you can do a fifth root. In either cases, you've got to hit the 5 first. Now, if I go to math, there's an option called X root. So if I hit math, if you look here at number 5, that's an X root. So when I hit number 5, it'll take that little fifth and it'll put it up there. And I can do 127. So it spits back our answer of 2.634. Another way that I could do this, and that's over here, this is the alpha versus alpha, this is the math versus alpha F1, F2 options. So in other words, what I mean by this is if you look above, I can go into math, and it's right there, number 5. Or if I hit alpha and F1, I get a whole list of options. If I hit alpha and F2, I get a whole nother list of options. So there, in this case, if you think that's quicker, you can do it this way. I can go down to the 6th root, hit enter, or number 6, number 6. And what it'll do is it'll leave me a blank to put in my 5, and it leaves me a 127 to put in my value, and I get the same answer. So I don't care which one you use. You can go to math and find it, or I can go to alpha F2 and find it there. Alpha F2 just organizes a lot of the stuff into one big space. All right, so next up, they want us to figure out what is 22.75 over 42.25. These nice calculators allow us to create a fraction. And again, we can do this two ways. If I hit alpha F1, I have n over d. That means numerator over denominator. It gives me a top and a bottom. Or I can hit alpha and then the X button, and it'll also make a top and a bottom. So 22.75 over 42.25, that spits back this decimal. Now, if I wanted, it says write this as a simplified fraction. This is not a simplified fraction. So what I'm going to use now is the math frac button. So what that does is it's going to take this answer and it's going to turn it back into a fraction. So I'm going to hit math, and right off the bat, you see arrow frac. Hit enter again, and it spits this back as a 7 over 13. So I can create a fraction using the alpha and the X button, and then if I get a decimal answer and I try to frac it back, it'll turn it back into a fraction. Now, this doesn't always work with every number. Like, for instance, if you take the number square root of 2 and you get a decimal and try to frac that back, it never turns into a fraction because that's what we call an irrational number. It can never be written as a ratio of two integers. And then we have the last thing I want to review with you is how to do an absolute value. So the absolute value bars, that's what those mean. So if I hit math, I can go over to number, and then there's ABS. Or, like I said, I really think that alpha F1 and alpha F2 are really slick. Alpha F2, and you see the very first thing is absolute value. So I want to do the absolute value of 22 plus 32 times negative 5. And I get 138. Now look, I know you could have just typed this into your calculator, like some kids would do it like this. 32 times negative 5, then add 22, and then just make their, oh, I didn't, sorry, let me try again. 32 times negative 5, and then add 22, and they get their number of, what am I doing wrong? Oh, yeah, and then you got to make it positive because it's in absolute value. Look, you can still do it that way, but the point is the calculator is trying to save us from having to do all that kind of stuff. All right, variable error. Always put parentheses around any variables in an equation. Oops. Variables. Okay, so evaluate x cubed to the negative 2 in our head. In other words, that would look like, if I put negative 2 in here, that would say negative 2 to the third. Well, negative 2 to the third would be, okay, so basically it's this. Negative 2 to the third. All right, let me try it this way. What's negative 2 to the third? So I grab my calculator. I do negative 2 to the third. Oh, it says do it in your head first. So that would be negative 2 times negative 2 is positive 4 times negative 2 is negative 8, and I get negative 8. Good. So in both cases, I got negative 8. Now do negative 2 to the fourth. So that would be negative 2 times negative 2, which is 4. Negative 2, which is 4. 4 times 4 is 16. But when I check it in my calculator, negative 2 to the fourth, it says negative 16. So what's the thing to remember? What's the difference? It's this, negative 2 to the fourth, versus negative 2 to the fourth. Your calculator is nice because it does the order of operations, but it's crappy because it does the order of operations precisely. So if I want the negative and the 2 to get raised to the fourth, if you type it in like this, your calculator did the order of operations. This exponent is strongest. That's 2 to the fourth, made it a 16, and then attached the negative. But if I want the negative and the 2 to be attached first, I have to use the higher operation, which is parentheses, and then raise that to the fourth, and then I get my positive 16. So if I was to clean this up, if I wanted to do negative 2x to the third minus y to the fourth, everywhere that I see a variable, I'm going to input that with parentheses. So negative 2, x is negative 3 to the third, subtract y is negative 4 to the fourth. Now, this one I really didn't need to put parentheses around it. But what I like to teach, I like to think about math as something that I just do over and over, whether I need to or not. So in this case, I don't want to try to remember, oh, I need parentheses here, but not there. So I just always do it with parentheses. So this would be negative 2 times negative 3 to the third, subtract the quantity of negative 4 to the fourth, and it spits back negative 202. All right, using a calculator to find zeros. Let's make a little note to ourselves as a reminder. It's been a while since we've done zeros. Zeros are x-intercepts. It's when the function is at a height of 0. It's when the function values equal 0. So if I wanted to figure out the zeros of this equation, I would start off by graphing that equation. So 2x to the, now remember, this is the x button next to alpha. 2x to the fourth, subtract 3x cubed, subtract 9x squared, plus 2x plus 3. Now I'm going to graph this thing. And if my window is good enough, my window is good enough. Now maybe you want to play around with the window a little bit. I'm really content with my y values. Even though I don't get to see this part of the graph down here, I don't care because I can see everywhere where it hits on the x-axis. Maybe I've got a lot of wasted space on the x, so maybe I would make my x go, let's say negative 3 for my min, and my max, let's say, is going to be 4, so negative 3 to 4. Now, you don't have to do this, but sometimes it makes your graph look a little bit nicer. Okay, so now we want to figure out these values. These are called zeros. If I go into everything good on your calculator when you're on this screen, everything good is underneath math or alpha F1, F2. When you're graphing, everything good is above trace in calc. Second, calc. I want to find a 0. Now your calculator is going to ask you 3 questions. It's going to say get to the left. So I'm going to move this cursor until it's on the left side. So there's the 0 about. I'm going to move a little bit farther to the left, enter. It should give a boundary. I'm going to move this cursor to the other side, hit enter. It's going to give me another boundary. And my answer is going to be 0 is going to be somewhere in between. So it's going to say set a left boundary, set a right boundary, and then take a guess. The guess is just moving the cursor as close as you can to where you think the answer is. So my first 0, so F has a 0 at x equals negative 1.5. Now that's just one of the zeros. We've got 3 more zeros. It hits x-axis, x-intercept, x-intercept, x-intercept. So I'm going to go second calc again, 0, move my cursor. Now I want to be on the left of it, so I'm going to stop a little bit before the 0. There's my boundary, enter. Now you can always check, look between the bars. If your zero's in between there, you're good to go. Then take a guess. So the next one would be negative 0.532. And then it's getting kind of repetitive at this point, but we might as well finish. I'm on the left side, enter. I'm on the right side, enter. And then I get 0.652. And last but not least, now here's a nice little trick. Second calc 0. If you know that the 0 falls between two nice numbers, you can just type those numbers in. So that's 1, 2, and 3. So my 0 is between 2 and 3. So I can just hit, for my left bound, I can just type 2, enter. For my right bound, I can say 3, enter. And then my guess, I'm going to say is, I don't know, 2.5, even though I know it's not that. So it ended up taking me there at 2.879. Using a calculator to find relative extrema and intervals of increasing and decreasing. So here's our function. Now, luckily, it's the same function that we just typed in, so we don't have to find it again or retype it in. Find the relative extrema. Now, relative extrema means mins and maxes. So it's the high points and the low points. So what we're going to do, and we're going to go back into, like I said, everything good is above trace here in calc, second calc. And if I look at my graph, the first thing we hit is a min. So I'm going to go calculate this minimum first. Second calc, I have an option number 3 called minimum, enter. It's going to tell me the same thing, left bound, right bound, take a guess. So I'm going to move my cursor. There it goes. I'm going to get on the left side, hit enter. I'm going to get on the right side, just a little bit, enter. And then you can just hit enter again on the guess, and it spits back that we have a min. So I would say F has a relative min of, now the min is the y value at a location that's the x value. So my relative min is negative 3.169 at x equals negative 1.108. You see how I wrote that up? Relative min means that it's relatively the lowest point on the graph. This point right here is relatively the lowest because relative to the points around it, it's a low point. Is there another low point on this graph? Yeah, there's a point lower down here somewhere. But relatively, that's my low point. Relative to the ones around it, that's what we call it, a relative min. Okay, the next thing I'm going to hit is a maximum. So second calc. This time I'm going to select number 4, which is a maximum. And this time I'm going to do my trick. It's going to be between, the max is definitely between 0 and 1. So I'm going to hit 0 for my left bound. I'm going to hit 1 for my right bound. And my guess is going to be something like, I don't know, 0.1. So I would say F has a relative max of, and it's relative again, because is this the highest point on the graph? No, it goes up forever to infinity. But compared to the points around it, it's relatively a high point. So it's a relative max of 3.170, 07, sorry, at x equals 0.106. And now my min, if you want to adjust where your min is, if you want to adjust your window to see lower, you can. You don't have to here. You could just like select this as your left bound and this as your right bound. But I want to play around and review with you how to adjust a window. So I only need to see lower on the graph. So that means I can go to window, and if I go to my Y minimum, that's my lower value. I'm going to randomly select something like negative 20. Let's see if negative 20 was enough. Not quite enough. So I'm going to go back into window. I'm only going to adjust my Y min because I want to see lower. I'm going to change it to -30, and now it's low enough. Let's go find that minimum. So I'm going to select number 3. I'm going to move my cursor a little bit to the left of it. Close enough. I'm going to move it a little bit to the right of it. Close enough. And then I'm going to take a guess. And I get F has a relative min of -21.396 at x equals 2.127. Now that relative min is also known as an absolute min because it's the absolute lowest point on the graph. But we were only focusing on relative. Relative mins can also be absolutes, but yeah, I'll just leave it at that. Okay, describe where F is increasing or decreasing. So this is, our graph is doing that at many different locations. It's decreasing, and then it's increasing, and then it's decreasing, and then it's increasing. A function is considered decreasing if its y values are going down from left to right, and then it's increasing if it's going up. So again, I've got to figure out where this transitions, and we transition from being a decreasing to increasing at a min or a max. So now I have to redo all this. I wish I would have thought of this sooner. So I have to do a min. My min is between -2 and 0. It's around -1. Okay, so what is my graph doing to begin with? So F I'm trying to find a good color. F is decreasing for all x that are an element of. So let me pause here and show you some notational stuff. This upside down A stands for all. This little E, it's like a C with a line through the middle, stands for an element of. So we're going to list all the x values that correspond to where the function is decreasing. So my graph starts decreasing from up at infinity, but I'm naming the x values. So I'm looking left and right. So my graph starts decreasing all the way at -infinity until this x value, -1.108. Now, if you stop decreasing, what do you start doing? I start increasing. So my graph stopped decreasing at -1.18, so it means it starts increasing at -1.108. And then it increases until here. So now I'm going to go second calc, that's a maximum, so I'm going to select 4. We already know it's between 0 and 1. Okay, so my graph then increases until 0.106. And if you stop increasing, you start decreasing. So we have to continue on with a union symbol in our new set, or our new interval, back up and decreasing. So now it's going to decrease from here until there. So second calc, that's a minimum. It's between, I don't remember, so I'm just going to say 2 and 3. No, 2 and 4. Oh boy. Well, let's see if I lucked out. 2 and 4. I think it's like 2.1. Let's see. Yeah, good. We got lucky. So then it stops decreasing at 2.127, and then it starts increasing, so I'm going to continue that on. And then it increases to the right, not up. It increases to the right the rest of the way. So when I'm talking about increasing and decreasing, I'm only talking about x values. I'm looking at y values, but I'm only talking about x values. And then last but not least, use a calculator to find the solution. Now, this is what we do when we have some sort of a crazy equation. I have this crazy equation equal to this crazy equation, natural log and sine. There's no way for me to get x by itself. So what's a nice feature on our calculator is that we can graph both of these. Remember, a solution is just where the two functions have the same y value. So if I graph this equation, if I turn this into an equation, and I turn this into an equation, and I see where they hit each other, That's a solution. So I'm going to go y equals the natural log, that's on the left here, ln, natural log, of 2. E is above natural log, so I'm going to hit second natural log, to the x, close it, subtract 1. Then my second equation is sine 2e to the x minus 1. Now, whenever I do trig, is before I hit graph, I always remind myself, your calculator should be in radians when you graph. So I hit mode, it takes me in here. Whenever you're doing an equation with trig stuff, make sure that you're in radians. So I'm going to do a zoom 6, get me back to the normal window, and see if that's a good enough window to see where they hit each other. Ooh, yep, there we go. So now I just need to figure out where they intersect. Again, anything good with a calc in the graphing section is above trace in calc. Second calc, I want to see, I don't want to know the 0, I don't want to know the min, I don't want to know the max, I want to see where they intersect. So I'm going to hit enter. Your calculator is going to ask you 3 questions. It's not left bound, right bound this time, it's first curve. So the first curve is the blue curve, hit enter. The second curve, see how it turned red, is the red curve. And then my guess, I'm going to move that somewhere about there. That's my guess. So my answer to the guess is 1.x equals 1.103. That's where these two graphs intersect each other. Now, there is an alternate way to do this. You also have the option of taking the equations and setting them equal to 0, or I can bump this over. And so my equation would now say natural log of 2e to the x minus 1 subtract sine of 2e to the x minus 1 equals 0. And now I can find zeros rather than intersect. So if I want to think of them as two separate equations, I would see where they intersect. If I want to think of them as one equation, so I've already got that first half typed in, and then I want to do a subtract sign, and I just got to retype what I had down here. E to the x, subtract 1, bump over. I just need to clear that guy out. And by the way, I'm putting a parenthesis here. You don't really need to put parentheses at the end of anything. Your calculator assumes them at the end. Okay, there's my picture. Now this time I'm going to go second calc. I don't want to find a intersect this time. I want to find a 0. So it hits the x-axis somewhere between 0 and 2 for sure. And I'm guessing it's going to hit somewhere around 1. And there's our 1.103 again, the exact same answer we got when we solved it as two separate equations. So it's up to you which way you want to do it. Okay, so you've got your, we got a little practice set there to practice some of this. Good luck.